Here we have dynamic multipoint VPN. This is a bit of a play off of that virtual tunnel interface. So with each of these topologies, we're basically just increasing the complexity a touch, but also enhancing our capabilities. We went from static tunnels to dynamic, meaning that we can leverage routing protocols, to DMVPN, which is going to give us the ability to dynamically construct these spoke-to-spoke tunnels. We'll run through this real quick. DMVPN provides fully meshed connectivity with a simple configuration of a hub and spoke. Now, what's neat about this is it supports dynamically addressed spokes. Historically, if we wanted to build connections between the spoke sites, each of them would need static IP addresses from a service provider and static configurations. The problem with that static configuration is every time we add a remote site, we're going to have to come back in and adjust all the other sites to include that site. It's the classic 2 to the n problem. So what this is going to give us is zero-touch configuration for the addition of new spokes. This is huge from a management perspective. Now, the neat piece that this gives us is, in that last bullet point, fully automatic triggering of IPsec tunnels. So typically what we'll have, and I'll show you a single spoke deployment here, but this could be, or single hub deployment, but this could be dual hub, of course, for redundancy. But what we do on the hub site, this might be headquarters, might be a data center. This is one place where you typically have that static IP address and traditionally tons of bandwidth. And then when we come across and we start to add these spokes, when each of the spokes connects into the hub, it's going to perform a registration process. And it basically says, hey, router, over here, we've got 10.110. And then this guy says over here, we've got 10.220. And this will be registered. It basically says if you want to ever reach the 10.110 network, come to this public IP. And this public IP address can be assigned through DHCP by the local providers. Now, what makes that really, really nice is the cost savings. How many spokes do we have? Imagine retail stores. You could have maybe 500 spokes. You used to have a monthly recurring fee for static IP addresses at each of these locations. But because DMVPN is so smart with this registration process, it actually uses something called NHRP. We can register with the hub site and say, hey, this is where we are. And then when we want to reach another network, let's say that we want to reach 10.330. We don't see it here in the topology, so we would query the hub. We say, hey, do you know about 10.330? It says, absolutely. That's actually going to be reachable over here at some other public IP address, which of course ties to a virtual tunnel interface, which is going to bring us to the private network, which is back here. Here we've got 10.330. So we can discover how to get to those other locations. And then the initial packet is going to come through the hub, but we're going to establish a spoke-to-spoke tunnel. And what that's going to do for us is get all the traffic load off of the hub, and it's going to decrease our latency because things are speaking directly to one another. Additionally, because this builds on the concept of virtual tunnel interfaces, we've got supports for dynamic routing. So this is where we say there's a zero-touch configuration for new spokes. If you bring up a new location, bring it online, it will call into the central site, register, and then we'll leverage perhaps OSPF or EIGRP to learn about the rest of the topology. Now, DMVPN can be deployed in 2 different modes. Both modes are going to use MGRE on the hub, but you'll notice that the hub and spoke, compared to spoke, this spoke-to-spoke mode is what most students that I speak with are excited to implement. This is where we get the spoke-to-spoke to connectivity. And this just requires that we leverage MGRE on the tunnel interfaces of each of those spoke routers. It's a touch more configuration, but extremely, extremely scalable and very high performing.